I got a question on the last problem in problem set 2B, and this is a hard one. It's not that hard, but there's a lot of steps and a little bit of algebra to it. So let's think this one through. Every one of us has a different. We have a different elasticity of demand. So I think this number here is different for each one of us, within some limits. Maybe there's 5 or 6 among the class. I'm going to solve it out for this case, and if you got a different number, well, follow these steps. Hopefully you did get a different number so you get some practice. Anyway, the question reads, at the beginning of this year, daily consumption of gasoline in the U.S. amounted to 344 million gallons. It is estimated that for every 10% increase in the price of gasoline, quantity demanded falls by 2.5%. That tells you that the price elasticity of demand is negative 0.25, by the way. That a 1% change, 1% increase in gasoline would lead to a 0.25% decrease in quantity demanded. All right, so by the end of this year, the price of gasoline is expected to increase by 40 cents from $2.80 per gallon. Of course, that's to $3.20 a gallon. Based on this information, what is the expected quantity demanded for gasoline at the end of this year? All right, this is made a little bit harder. Actually, the hard part about this problem is that before you click this problem, if you look at the directory, it says Midpoint Method. If I were giving you this problem in an exam situation, I would tell you Midpoint method or use whatever method you want. That's usually what I do in exams. But they specified Midpoint Method, which makes this just a shade harder. Lucky us, huh? All right, so what do? Well, the general thing we do for problems like this is to realize that, oh, okay, well, the elasticity of demand is equal to the percent change in quantity demanded divided by the percent change in price. And as you remember, you could say the same. It's the proportionate change in quantity demand divided by the proportionate change in price. This is just an easier shorthand way to write it. I tend to use proportions more. Well, here essentially we're asked what the percent change in quantity demanded is, or we're going to have to work with that. We have to solve for Q1 from that formula for percent change or proportionate change in quantity demanded. So let's isolate that. That's going to be key to doing this problem. The percent change in quantity demanded is equal to the elasticity of demand times the percent change in price. And notice what this problem gives us. It gives us the elasticity of demand. It gives us enough information to calculate the percent change in price, or the proportionate change in price, and it gives us even half the material we need to calculate the proportionate change or the percent change in quantity demanded. So now we're set. This is going to be a few slides worth of material. All right, so let's get going on this problem. We know that the proportionate change, well, I'm going to write it in percent change while I'm doing it in shorthand. I'll quickly change to proportionate when it gets time to solving it. Actually, let's do it in proportionate now. The incremental change in quantity demanded divided by the level of quantity demanded, that's the proportionate change in quantity demanded. That's going to equal the elasticity of demand times the proportionate change in price. And we're given that the elasticity of demand is negative 0.25. You're going to have a different number. I had 0.19, negative 0.19, and the one that came up for me. This is a student's screenshot. Then we know we have enough information to calculate this proportionate change in price using the midpoint method. So P1 minus P0 over the midpoint, which we can just get by looking at it, but it's a little ungainly to write. But P0 plus P1, the quantity divided by 2. Well, we know what that is, right? The price went up by 40 cents, 0.4, And the midpoint between 280 and 320 is actually, we don't need to do any calculations, most of us, to see that that's 3. And that turns out to be 0.133. So we know that remember that our quantity demanded, the new quantity demanded, that's what we're asked for, minus the old quantity demanded that was 344 million. The millions are going to cancel out, so I'm not going to worry about them. We know that that incremental change in quantity divided by the midpoint of quantity, 344 million, or we're going to do this in millions, plus Q1, the quantity divided by 2, we know that's equal to the proportionate change in price, 0.133, times the elasticity of demand, negative 0.25. When we multiply those together, we get negative, I'll look over at my notes here, 0.033. So now it's just a plug and chug effort. We know that this quantity here equals this quantity here. So we've got one equation, one unknown. It's just plug and chug time. So let's go ahead and do this. I know that Q1, I'm going to multiply both sides by 344 over 2 plus Q1 over 2. That's another way to say this denominator here. All right, so that's going to free up Q1 minus 344 on the left side, and then on the right side I'm going to have negative, I'll just use parentheses, just maybe that clarifies things, negative 0.033 times the quantity 344 divided by 2, 172 plus Q1 over 2. And yeah, you're going to have to use your calculator for this, but ultimately it's not that hard. It's about freshman, sophomore year in high school math, which, yeah, it's a little bit tedious, but I know you guys can do it. So I'm going to just simplify this expression on the right-hand side and then group terms, and then we'll be done. 344 equals, when I multiply all this out, I get 0.033 times 172, according to my calculator, is negative 5.643. And then 0.033 divided by 2 that's a minus, so I'm going to be, that by my calculations is 0.0165 times Q1, and then I'm going to add 0.0165 Q1 to both sides, and then add 344 to both sides, and then regroup, and I end up with 1.0165 times Q1 is equal to 344 minus 5.643. That gets me to 300. Oh, what does that get me to? That gets me to 338.357. They only ask us to report to one decimal place, but by doing it to 2, or in this case 3 decimal places, it just, I make sure my answer isn't off because of rounding error. So now I know Q1 is equal to 338.357 divided by 1.0165, and when I pop that baby into my calculator, I get 332.86, which rounds to be, they only want one decimal, 332.9. So that, a little bit of algebra, granted. So be careful as you do your step-by-step, and here, that's how you do it.